Hello students, my name is Fahim. I'm a research scholar in the field of additive manufacturing and 3D printing. In our last video, we have seen that there are various options that are available on the right hand side interface of the software called as FlashPrint. If you want to learn the options again, you can go through the link that is available in the description. In our today's video, we are going to learn about the various important slicing parameters of FDM process. For that, you will go to the start slicing option, and there are various headings that are available on the left hand side. First heading is the printer option. In that, you will have to firstly select the machine type, which we have already selected as Guider 2nd S. Here we cannot change the machine type. We have already selected it before importing a part onto the platform. I have already explained in the last video that how can we change the various machine types that are available in the software. Next we have the nozzle size. As I have already explained that nozzle can be only replaced manually. So if you want to change the nozzle, you can replace the nozzle size manually and then you can select the nozzle size accordingly in the software. As of now we are going with a 0.4 mm nozzle. Then we have material type. There are various types of materials that are available in the FDM process. For example, PLA, polylactic acid, ABS, that is acrylonitrile, butadiene, styrene, polycarbonate, nylon, PETG, TPU, HIPS. So there are various kinds of materials that can be used in this technique. As of now, we will be selecting the option called as PLA, that is polylactic acid. The material is usually in the form of a filament or a wire whose diameter is usually 1.75 mm. Then there is a setting called as slice profile. Here are three options available, that is fine, fast and standard. If you are selecting fine option, then the process parameters will be automatically selected in such a way that the mechanical strength and the quality of the parts is very good, but the time taken by the parts will also increase. Now if you are selecting the fast option, then the parameters will be automatically selected in such a way that the time taken by the overall part is less, but the quality and the strength of the parts may be compromised. The standard option is a compromise between fast and fine, that the parameters are selected in such a way so that the mechanical strength and the quality is comparably good while the time taken is also less. So the profile to be selected depends on the application of the part that you are going to 3D print. But for us, this slice profile does not make any sense right now because we are going to select all the process parameters manually. So it doesn't matter whether we are selecting a fast, fine or standard option. Now we have a setting called as extruded temperature. It's also called as printing temperature. It is a temperature at which the filament or the wire is extruded from the extruder head onto the platform. The extruded temperature of different material is different. For example, the extruded temperature of PLA is in the range of 210 degrees centigrade to 220 degrees centigrade. For ABS, it is between 230 to 240 degrees centigrade. And for polycarbonate, it is between 300 to 320 degrees centigrade. So for different polymeric materials, the extruded temperature varies accordingly. So if you are selecting the material as PLA, then you can go with the extruded temperature as 215 degrees centigrade or even 220 degrees centigrade. If you are selecting ABS, then you can accordingly go with 235 degrees centigrade to 240 degrees centigrade. Now there is one more setting that is called as platform temperature. We need to heat the platform to up to a certain temperature. Now there is a question firstly, that is why we need to heat the platform. The answer to this question is that heating the platform helps in the proper addition of first layer with the bed. It also helps in avoiding the warping of the parts during the printing process. It also helps in the strong fusion of different layers that are deposited over each other. So we should heat the platform up to a temperature called as glass transition temperature. Different materials have different glass transition temperatures. For example, for PLA, the glass transition temperature is around 60 degrees centigrade. For ABS, it's around 110 degrees centigrade. For polycarbonate, the temperature is around 150 degrees centigrade. The heating of the platform up to the glass transition temperature make sure that the layers that are deposited on the platform does not rapidly cool down, but they still remain at the glass transition temperature, so that the successive layers that are being deposited strongly fuse with each other and helps in making a stronger part. So for different materials, the glass transition temperature is different. For PLA, the glass transition is around 60 degrees centigrade. For ABS, it's around 110 degrees centigrade. For polycarbonate, it's around 115 degrees centigrade. For different materials, the glass transition temperature also differs. So we will select 60 degree if we are going with the PLA as the material. Then you can also select the control module, that is, you can select the right extruder or you can select the left extruder. If you are using a dual extruder printer, for example Creator 3 Pro, then you have to select that which extruder you are using for printing, whether it is a left extruder or you are using a right extruder or you are using both the extruders at the same time. But as of now, you can go with the right extruder because the Gata 2nd S series is a single extruder printer. Then there is one more heading, that is general. In the general option, we have two important parameters that need to be taken care of. One of them is layer height and second one is speed. Please note that we are going to learn about only those parameters here which are important to print a very good 3D printing part. The question here is, what should be the layer height of a particular part? For that, we will take an example of I have a 3D printed part in my hands. You can see the part. For example, if I select this part and the height of this part is 100 mm and I decide that I will start printing this part with 1 mm layer thickness, then the number of layers to complete this part will be 100. Now I will change and I will say that I will start the printing of this process with 0.5 mm layer height. Then the part will complete in 200 layers. So it can be seen that the same part is taking either 100 layers to complete or it can even take 200 layers to complete. So what should be the number of layers to complete this part? That means what layer height you should choose. So there is no standard for that. It only depends upon the application of the part which you are printing. For example, if the part is going to have some functional aspect or it is going to be used in any kind of engine or in any machine, then it should have a good mechanical strength, it should have a very good dimensional accuracy. For that purpose, you should choose a lesser layer height. That means the number of layers will be more and the quality and the mechanical strength of the part will be very good. Now if you want to just print a part where the dimensional accuracy or mechanical strength is not important, only the time taken is important, then you can go with the higher layer height. That means less number of layers. It will print the part in lesser time, but the quality and the mechanical strength might be very low. So it depends upon the application of the part. Accordingly you can choose the layer height. Now for example, if we are choosing the layer height as 0.2 mm, then there is the first layer option. What should be the first layer height? As you know, as the foundation of a building is always important, similarly for a good 3D printing part, the first layer is always important. So it is important for the first layer to stick with the bed. For that purpose, we increase the first layer height so that more amount of material is extruded from the nozzle and the addition of the first layer with the bed is stronger. For that purpose, we usually increase the first layer height by 20% more than the normal layer height. For example, if the normal layer height is 0.2 mm, then the first layer is around 0.24 or 0.25 mm. Then there is one more heading, that is the speed. Here we have two options, that is printing speed and trowel speed. The printing speed is the speed of the extruder head when the printing process is going on, that is the material is being extruded from the nozzle onto the platform. The trowel speed is the speed of the head when the head is moving idly, that is no material is being extruded from the nozzle. So during the trowel speed, the head is usually idle. The trowel speed can be more than the printing speed. Usually it is around 20 to 30% more than the base printing speed. Now for different materials, the printing speed is usually different. For PLA, we can even go up to 100 mm per second. For ABS, the printing speed can be around 60 mm per second to 80 mm per second. But for higher temperature materials, for example, polycarbonate or composites, the printing speed should be between 40 mm per second to 60 mm per second. This is because these materials have high glass transition temperature, and by keeping the speed in the range of 40 mm per second to 60 mm per second, enough time is given to the layers to cool down before another layer is being deposited. There are another options available in this section, but you need not to change them as of now. We can change all of these parameters for the purpose of research. If you are going to do any kind of research, you can see the impact of various parameters on the mechanical strength or on the dimensional accuracy of the parts. Then at that time, you can change all the parameters and see the effect of various parameters on various characteristics of the parts. Another section is the shells. Shell means the outer boundary or outer periphery of the 3D printed part. When I have selected the shell count as 1, the shell thickness of the part will be 0.4 mm. 0.4 mm because the diameter of the nozzle that is being used is 0.4 mm. So the maximum amount of material that is extruded will be 0.4 mm in width. If I increase the shell count to 2, then the shell thickness will be multiplied by 2, that is it will become 0.8 mm. If I will go for 3 shell count, then it will be 1.20. Similarly, the more number of shells, more will be the thickness of the outer boundary or outer periphery of the part. Now we have to complete the part by placing the bottom layers and the top layers. For that, you will go to another section, that is infill. Here we are going to put the top solid layers and bottom solid layers of the part. The number of the top solid layers and the top bottom layers should be same as the number of shell counts. For example, if we have selected 3 shell counts, then you can select 3 top solid layers and 3 bottom solid layers. Once we have completed the bottom solid layers, the top solid layers and the shells, then the outer periphery or outer boundary of the part is completed, but from inside the part is still empty. The whole strength of the part will depend upon the thickness of the shell. Now in order to fill the part from inside, we are going with the option fill density or infill density. When the fill density is 0%, that means the part is totally empty from the inside and its whole strength is dependent upon the shell thickness. If we increase the fill density from 0% to 100%, then the part becomes completely solid, that is, it is having the maximum strength. Now if we decrease the fill percentage from 100% up to any percentage, that means the strength of the part will decrease accordingly. Also, we can choose what type of fill pattern we want to place inside the part. For that, we have different options. For example, we have line option, we have hexagon option, we have 3D infill option, we have triangle option. In the line type of infill pattern, the first layer will be laid down at 45 degrees from one corner to another corner, and from another side it will cross at 90 degrees. So a line type of structure will be laid down from the inside. I will show you the slice preview of this type of structure. We will go to the slice option. Then we can go with the slice preview option, and I can show you how is this. Here you can see that we have selected 3 number of shells, and from inside the lines are being laid down as 45 degrees, and from another side these lines are crossed at 90 degrees. So we have a line type of infill pattern. If we increase the fill density from 50% up to 80%, then the spacing between these lines will be decreased and more number of lines will be laid down, then the strength of the part will be increased. But more material will be used and the overall build time of the part may also increase. So the percentage of material that is being filled also depends upon the application of the part where the part is to be used. Going back to the slicing parameter option. Now if you are choosing the hexagon option, then the infill pattern will be in the form of hexagons. So if we slice it again so that I can show you how it will look from the inside, we will again go to the slice preview option. Then we can go to the layer structure option. You can see that we have the same number of shells, that is 3, but inside we have a hexagonal type of pattern. If we increase the fill density then the size of the hexagons will decrease, but there will be more number of hexagons. The strength of the part will increase, but the material used will be more, and time taken by the overall part will be more. Going back to the slice option, in another section we have the supports option. As I have already explained in the last lecture, that is, we have two support type options. One is the linear supports and another one is tree-like support. We can choose any of the supports. If we are choosing a linear support option, then there are a number of settings we can perform here, but we do not need to change these settings as of now. Only one thing I would recommend here, that you can just decrease the support thickness up to 60% so that the supports can be easily removed from the part. Now we have another option that is called as raft. Raft is a kind of a platform that is laid below the surface of the part that is being 3D printed in order to make the addition of the part with the surface of the platform strong. A raft is generally used for the parts whose bottom cross-sectional area is generally less. For example, if we want to print a part like Eiffel Tower, or we want to print a part like a pen, in such case, as the bottom cross-sectional area of the parts is less, and once the part starts printing and it attains the height, there is always a chance that the part may fall down before the part is completed. So at that time, when we are using a platform called as raft, it increases the addition of that part with the bed and does not let it fall down before the part is completed. So you should remember that the raft is particularly used for the parts whose height is high and the bottom cross-sectional area is less, and in such cases the parts may fall down because of less addition with the surface of the platform. So if you want to look how this raft looks like, you will go to the slice option. Then we can slice preview this part and we can go to the layer number 1. You will see that the first layer of this raft is very thick. This increases the addition of this raft with the platform. So once the layers are completed, you can see second layer, third layer, fourth layer and fifth layer. After the fifth layer, the first layer of the part is started. So the raft helps in the addition of this first layer of the part with the bed surface, and it does not let it fall down. Close preview. Now there is one more important setting that is called as brim. So for that you will go to the section addition and you will scroll down. There is an option called as brim. The brim is particularly used if we are printing with ABS and the surface area of the model is large. You will notice that the edges of this part have bent from the corners. This defect is called as warping defect or curling defect. It happens in particularly when we are printing with ABS. It happens because you know that these polymeric materials, once they are heated, they expand, and once they cool down, they start to shrink. When the layers are being deposited on the bed and the first layer starts to cool down, it shrinks. When the second layer is laid down on the first layer, it tries to drag the first layer from the bed surface, which causes the defect called as warping or curling. That is, the edges of the part are lifted from the surface of the platform and they start bending. So in order to avoid this defect, we use the option called as brim. So the brim helps to anchor the edges of the model to the plate to avoid warping. So you can see how does this look. For that we will just confirm that we are using brim and slice the part. You have to also remember that brim is not a platform that is placed at the bottom of the part. It is only placed from the sides. You can see in the slice preview. So if we go to first layer, you can see that only the brim is placed all over the part, not below the surface of the part. So this brim will make sure that the part does not detach from the platform from the corners, and it makes the addition of this part stronger with the platform. This way we can avoid the warping or curling defect in the parts. Now in another section, that is cooling, we have cooling fans that are available with the 3D printers. There are particularly two types of fans being used. One is attached in the extruder and another one is usually on the back side of the printer. Back fan is usually always kept on in order to take out the heat that is produced inside the printer. The fan that is attached with the extruder is usually kept on when the first layer is being printed. Otherwise, it can be kept off. In the advanced section, there is one more important setting that is called as path width, or it's also called as road width. The default value of this path width is usually 0.4, because you know that the nozzle that is attached to the printer is of 0.4 mm. So the material that is being deposited through the nozzle will be 0.4 mm in width. But you can also increase the path width, or you can also decrease this path width, so that the amount of material that is being deposited on the surface of the platform may be increased or decreased. This option is usually used in case of research. If you want to see the effect of this path width, it has a great impact on the mechanical strength, or we can say the dimensional accuracy. In such cases, you can change this path width. You can even decrease or increase this path width up to any value. So these are some of the important process parameters that I have explained in this video. If you properly set the process parameters in the software, there are high chances that the part will be printed with a better mechanical strength and dimensional accuracy. So finally, once you have set all the process parameters, you will go for the slice option, and you can slice preview before starting the printing process. You can see the process parameters you have set. For example, you have set the layer height as 0.2 mm, you have set the shell count as 3, fill percentage 50%, fill pattern as hexagon, and other process parameters. So you can see the estimated printing time also. For example, this particular part is taking 4 hours and 2 minutes, and the estimated material usage will be 52.93 grams, or in meterage you can see that 17.75 meters of the wire or filament will be used. Once you are satisfied with the process parameters, you will go to this arrow, and now you can save this file on the desktop, or you can see that the format of the file has been changed from STL to GX. Now this is a G-coded file. It means that the tool path has been generated. Now this file will be used as an input to the 3D printer, and we can start 3D printing the part. So this is all about the slicing process in the Flash Print software. In the next video, we will learn about the operation of some of the FDM machines that are available in our lab, for example Guider 2nd-S or Creator 3 Pro, and you will see how we can set up the machine and how we will 3D print a part in the 3D printer.